and the prototype chain. All right, JavaScript does inheritance a little bit differently than from what you've already known. We're going to talk a little bit about those differences. We're going to try our best to understand how JavaScript actually does that and why we do it the way we do it. So the outline is we just want to understand the benefits of sharing properties and behavior, which is essentially inheritance. How does it work? And then how do we actually use it? So the first thing is, what is inheritance? I've noticed that even if I have the answer up and I zoom in and highlight, this is not the class that likes to shout out, so I will just read it to you for funsies. And that is when one object gets access to the properties and methods of another object. All right, so you've seen this before in Ruby, where you can have like class and you can do robot, and then boop, and then there'll be some sort of like define initialize method here, blah, blah, blah. And then how does Ruby or any real object-oriented programming language absorb the methods and the properties of another class? Right, it does this, right? And it does like machine, or you do something like active record, and then I think it's like base, right? And so what this is saying is that this robot class will pull everything from active record base. It is sharing all of the properties and methods that active record base has. And that's basically how inheritance is done, yeah? The idea here is that it's important because if everything in the machine class, right, is shared by any of these subsequent classes, like robot should be pulling from probably like machine. And then the machine class can then pull from active record base. And so through the magic of inheritance, it should have access to all these things. So you can even see this here where I can go into the IRB. And if I were to do something like array, I can see, just kidding, I can look at an array, 1, 2, 7. I'll throw you off. No, nobody. Okay, great. So I can check its class, right? It was just an array. And then I can even check its ancestors. And so the array will inherit from the enumerable class, which inherits from object, which inherits from kernel, which inherits from the basic object, the highest level object. And so that's how object-oriented programming is done, and this is the classical form of inheritance. It's only called classical because this is how basically it's always been done in all the object-oriented programming languages, right? So like Ruby will do it, Java will do it, any object-oriented programming language inherits very much like this. And here's kind of where like the issue lies. The problem is, what if I wanted the array to pull some of the innumerable methods and properties, but not all of them? How would you kind of do that? Right, there's like this module system, but then it gets really tricky because then I need to create a separate module that the enumerable needs to kind of like mix in with, and then also the array will like take in from the module, but then it doesn't get all of the enumerable stuff. So you could see that with object-oriented programming and inheritance, it becomes really muddy to split things up modularly because of how tricky it can become when it comes to inheritance. Inheritance will pull everything from it. So JavaScript does it a little bit differently, and we'll kind of talk about that. So when we first create objects in JavaScript, bloop, bloop, right, this is how to do it. If I wanted to create a brand new robot, I would simply do const robot and then like all of these things, right? So I can do const robot 1. Oops. Oh no. Bloop, bloop. So we're going to put this under the category of object literals. Right? And that is like I'm just making a brand new object, literally using the object literal syntax. So in theory, if I wanted to make another robot, I would say const robot equals to, and then literally a brand new object. So this is object literal syntax, and I can put name. You guys have like a robot you guys like? Oh, Bender. Bender's great. So weight, don't worry, we'll have plenty of them, so think through. And how much does Bender weigh?
26.
26, very good. I don't know what that means, but sure. Speciality is bending. He's a bending robot, very good, yes. So what's the issue with this object literal creation? If I want to make a brand new object, what would I have to do? well, yes, I'd have to repeat myself, but ultimately I have to type in that whole thing again, right? I have to put in like this object literal syntax, I have to put the name, I have to make sure I put in all the commas, right? And that can get pretty tedious. The problem with this is that it's tedious and it is error prone. Like how many times have you seen me alone, how many times have you made a typo in your code? Actually, I just realized that that is like not a yes or no question. So like by raising your hand, you're like, yes. Yes, I have made typos. Okay. So, cool. So now let's think of like a better way, TM. What's the better way? The idea is that I can have what is known as like a factory function. So I have this function, bloop, and then now I have this function. So if I wanted to make a brand new robot, what I can do is simply go const robot3 is equal to, and I invoke the robot factory function. So I have robot factory, and then I pass in the name, right? So, I mean, what's another robot? Oh, now you're quiet, huh? Wall-E, right? Little wall-E like arrow syntax? No, just kidding. Hey, JavaScript joke. So, and how much does wall-E weigh? 7? I don't know what that means for you guys, but little 8,000? Oh my God. And then what is wall-E's specialty? Planting? Swimmer, sure. So if we take a look at this code, the idea here is, it's going to make the robot for me inside the factory, and then it's going to return the robot. So because it returns a robot itself, when I look at robot 3, I should see a key value pair of robot 3. So if I were to save, and I were to actually like exit out of here, open index.html, I take a look, and I see what is robot 3. I just see this object because it returns the robot object for me. That's what the factory function is doing. So that being said, this is an easy way because all I have to do now is do robot 4 and call that robot factory again. It is less error prone because the name, the weight, and the specialty are always defined. I just have to pass in the arguments in the correct order, just like you would in Ruby in the define and initialize. So the idea here is you just want to kind of extrapolate and abstract one more level. You have a question?
Yeah. Can you, like, remember in the last one you had like a person class, but like the function had like person and then all characteristics in a hash?
Yeah, I'm going to get to that.
Is that like how would you make?
100%. I'm going to get there, but I like where your head's at. So notice how I have a name, right, that I'm passing in, and then that's going to be a key of name. I have weight that I'm passing in, and that's going to be a key of weight. If I have the key and the value pointing to the exact same variable name, then I can use what is known as like this ES6 key value assignment shortcut. So because name points to name and weight points to weight, specialty points to specialty, I can simply put name, weight, and specialty because the key and the value are the same. Cool? This is just syntactical sugar if you would like to use it the ES6 shorthand way. That's all. All right? What I wanted to show you is that you can do something like this and not to be scared or confused because you'll run into this object literal syntax and then you'll see one argument here and you're like, huh? And so this is just the shorthand. Okay?
Is there anything that we have to do to install ES6?
No. There's nothing that you need to do to install ES6. It's simply that if you write it a certain way, the browsers that are running the modern JavaScript, something like Chrome, Firefox, Safari, then it will understand that. But if you were to write this sort of syntax, and then somebody that's on a very old version of Internet Explorer, it will sort of error out. So you'll look at the console and it'll be like, I don't know what this is. Right? You're missing a key and a value. I only see one argument inside your object. Cool? So there's nothing to install. That's a very good question. I'm sure that was like on some of your minds. So, all right, cool. So the next thing is like, what if I wanted to add some sort of functionality to the robot? In the same way that in Ruby, let's take a look. In Ruby, I have this initialize method, which is kind of the robot factory function so far. But if I wanted to put something like recharge batteries, right, how would I do that inside this robot factory function? How can I get this robot to make sure that it has the same level of functionality? Each one of these robots that I make has a method on it that can then recharge the batteries. Well, let's think. Ready? These are essentially keys that points to values. In the same way that we did the thing for dog, right? Let's do this. This might help you a little bit. Right? If each one is on its own line, couldn't I just do a recharge batteries functionality here that actually points to a function? And then all this does is it returns something like money. Oops, oh, embarrassing. Money, right? This dot name is recharging. Smiley face. Mega smiley, more smiley faces. More smiley faces. Oh. And so here, let's actually see what's happening here then. Let's make another robot factory. Oop. You guys got a robot name for me? R2D2, cool. And how much does R2D2 weigh? 27. I don't even know what that means. And what is R2D2's speciality? What? Sassiness? Sassiness. Very good. Huh. Surprised that didn't give me like a spelling error, but whatever, sure. That is the most S's I've wrote in a word. Sassiness. Very good. Okay, great. So let's actually take a look at this, right? If this is correct, I should be able to do robot3 dot name, gives me the name, robot3 dot weight, robot3 dot specialty, and then robot3 dot recharge batteries. From what we learned from this lecture, what should this be? It should point to, this should point to the robot, and then this dot name, therefore, is the robot dot name, which gives us whatever that argument winds up being. So I should test that with robot3. So let's do that. I now have robot3. Sorry, I have to refresh. Embarrassing. So robot3 dot name. Okay. Robot3 dot recharge batteries, which is a function. So now I'm creating that method on it. So if I do robot3 and I invoke it, I in fact see while E is recharging. Remember the context execution, this dot operator, I'm invoking the method recharge batteries onto robot3, the object. So the object 3 is like this. So, let's take a look. Robot3 dot recharge batteries. Does robot 4 also have a recharge battery key? Okay, which is a function. Let's see what robot 3's recharge batteries function is. They look the same, right? The weird thing is, if it's the same, theoretically, should robot 4's recharge functionality be the same as robot 3's recharge functionality? It's false. Even though they're the same. Here's why. When I created robot 3 and I created robot 4, each one of them has their own unique key value pairs. So in the same way that if I did robot3.name, I get wall-e, would this make any sense to you? Why would that wind up being true? Because when I initialize, I created it from the factory, I set its name. So each one of the key values inside the object is unique to the object. The object stores the key values in memory. It's assigned its own key value pairs in memory. So the theory is, if I make all of these robots, how many times am I creating the recharge batteries function for each one, right? Which is wasting a ton of memory. I don't actually want to do that. So is there a better way? Well, the idea here is that what if, right? I'm just going to scroll through the notes here. inside here, this functionality, okay, right, ugh, dang it, where's my, did I not do it in my README? Huh, okay, let's do it this way. The idea here is that I want to actually not create this robot recharge battery functionality every single time. It should be unique. So what if I did this? I made a function and I said recharge me. Boop, 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 boop. Cool? And all this did was it returned this right here, except is mega charging. Cool? Great. The idea here is that I can in fact create a robot. So what about robot 3? That already exists, right? Does the key of mega charge exist on robot 3? No, it doesn't. So couldn't I just assign it to be a function like recharge me? Oh man, I just realized that that was Ruby. Gets lost so fast. And then I can do robot 4 dot mega charge is equal to recharge me. They are now pointing, there's a new key in each of these objects that points to the same function. So no matter how many robots I create, I'm not creating a separate function in memory. I just create one function and have all of them point to that one function that exists in memory. So that's going to give me huge savings, right? If I have 20,000 robots, they're all going to point to one function I've created, as opposed to creating 20,000 robots with their own recharge me function 20,000 times. That's the same.
Why wouldn't you invoke recharge me?
Say again?
Why wouldn't you invoke recharge me?
Remember what happens when you invoke.
Well, those are the string.
It's the... Okay.
But like you still want that string, it's the same thing. Once that like that string is a constant, this is being recharged strings.
If I invoke it, what is the return value of recharge me, the baseless function of this.name? Great. So that means I'm storing robot 3 megacharge to be window is megacharging, which we don't want. We want to keep the this keyword so that at the time of execution, in its execution context, it will evaluate. The this keyword evaluate at that time.
What is megacharge?
Oh, it's just a random key that I put. I could have put like Aniket if I wanted to, and now they're both Aniket. Too late. You're in the README forever, and your class will have it, but they'll remember. I mean, if you're not cool with it, I'll change it back. You sure? Legend. Great. Good question. Okay, I'm also going to get rid of this.
So by not invoking it, you're just basically giving them access to that function?
Yes.
Okay.
I'm storing a reference to that function now inside a key of Aniket. So what I'm trying to say is now I should have, in theory, robot 3 should have a name, a weight, a specialty, the recharge battery function that it was initialized with, and now because I added this key, it also has an Aniket key, right? So that means that robot3.Aniket is a function, which means that robot 3, because robot 4 points to the same function, a baseless function, would robot 4.Aniket be true? So now it's the same thing. Powerful. Cool? So the idea here is, all right, going back to this, let's talk a little bit about what Ruby is doing. Ruby, in fact, does it that way. Inside the template, when I do robot, it will create and encapsulate its own functionality so that when I do robot1.new, and I make robot 1, I do recharge batteries, it's actually going to create its own method inside that class every single time. So this is kind of one of the reasons why JavaScript does like this object instantiation. And it's a little bit different than this class syntax. So far, so good? Great. Let's talk about prototypical inheritance. So the first thing I want you to take away is that the classes that you know right now don't actually exist in JavaScript. If you see the class keyword as the syntax, it's technically syntactical sugar, and I'm going to break down what it's actually doing, and then I will show you the code that it actually transpiles back into. Cool? So JavaScript has no real classes inside its programming language, and I'll explain what that means. So what it does, however, is this prototypical inheritance. And so let me try my best to explain it. Oh, I did do it. So I have the robot factory, and I pull out the function of recharge batteries outside. So I just do this, bloop, 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 right? I do this. Bloop, 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 bloop. And now, if I were to refresh the page, these two robots do not have recharge batteries organic to it because in the instantiation it doesn't exist. So I can do, I'll leave you in there, right? Robot 3 dot regular charge is equal to recharge batteries, that function, the one that I just pulled out. So it's just another example of how you can pull it out of that sort of like template and make it so that it's not being created every single time. Following along? All right, so that being said, there has to be a better way. Let's refactor our code using this object.create. So instead of the object literal syntax, we have a factory function, and then another way to create objects is this object.create. Let's actually take a look. I can make this template, and instead of a function of robot factory, I simply create this robot template. I have a name set to null, weight set to null, specialty set to null, and then I have this recharge batteries functionality. If I run object.create and I look at robot template, this is what's going to happen. I create a brand new object and I default set all of its attributes to null. So let's actually take a look at that. So robot, what is it, 5? Robot 5. And I do object.create. Let's take a look at what that's doing. Refresh. What is robot 5? It's just a, yeah, it's just an empty object, right? That's fine. So,
Does it like define what should be in there?
So I'm gonna get to this here in a second, but like if you open it, surprise, there's this proto, and on it already is this name, recharge batteries functionality, specialty, and weight, which are all null. So it's pulling from sort of like this template that it knows about. So if I were to do robot5.name, I get null, not undefined, which I would have gotten had I not set this to anything. So let's take a look. If I do robot5.name, what's this name of this robot? Iron Giant, right? So robot5.recharge batteries is a function, and I can invoke it. And so the Iron Giant is recharging batteries because I've built this as a template. So object.create will do something very important, and that is it's a method on an object because literally .create is a method on the capital O object using an existing object as the prototype, right, of the newly created object. So what does that mean? Well, the idea here is that in the object, if I check its proto, it'll point to everything inside this robot template. Very similar to how the classes work in object-oriented programming for like Ruby or Java. Cool? So the problem is like I then have to actually set the name, the weight, the specialty on all separate lines. The prototype is a key that I'm assigning. It's a special type of key. So if I were to look, robot5, and I do __proto, I see the template that it pulled from. So far, so good. I see the template that it pulled from. The idea is that this underscore underscore proto is a separate object that has the key values that I want for this robot. So let's take all of this and kind of pull it all together. The idea here is I have a function called recharge me, right? What if I had an object that says const, right? All my robot functionality, and that's equal to an object. So the first thing would be I want to be able to charge, and that is going to be a function. And this just returns charging. What if I have another functionality? What other functions that can robots do? Sure, destroy. And that's going to be a function that simply returns all your base are belong to us, right? And another function is bend, right? And that's a function, and this is called return, and says get bent. Very good. So now I have this object that has 3 key values that are essentially functions. So far, so good. Remember how I added this function to a robot I created from the factory, and that was simply robot3.key, new key, and it was the function itself. So far, so good. So if I did robot3 dot more functions, and that pointed to, well, an object, and that was all my robot functionality, what do you think robot3 dot more functions will give me? An object that has what? 3 functions in it. So in theory, I've just added 3 new functions to robot3. And so what this basically is, instead of more functions, what if this was underscore underscore proto? This right here is going to give me all 3 of those new functionality keys in this object. So that's basically the idea behind like this prototype. So if I'm looking at it again, given that context, all right, the underscore underscore proto is giving me name, weight, specialty, and recharge batteries because it's pulling from this template here. That's what object.create is. It's pointing any brand new object to a prototype that has this functionality in it. So far, so good. So,
It'll change the name of proto, like to like whatever you want to reference it to, like so you want the template to.
no. So the question is, can you change this underscore underscore proto? No, it's built in. You'll even see that it's kind of like faded out a little bit. It's a private. It's a private object that's attached to this object. So let's do this right here. I have my awesome web app. It's awesome. Remember that? Powerful. Cool. So what I can have is I can have robot 1. I can have robot 2 is bigger apparently. And it has like name, weight, specialty, name, weight, specialty. And they're both different. They're unique to each one of these robots, which should make sense. If I have this 4th key, right, and I want to call it extra functions, right, and I have a 4th key, extra functions, blah, 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 and I point it to an object. And this has key 1, key 2, key 3, key 4 that are all functions. This is how I'm gaining the functionality for robot 1 and robot 2 by not recreating them, but pointing them because objects are passed by reference. I can point this key to 4 more free functionality for my robots. This right here essentially is the underscore underscore proto. Underscore underscore. The reason they named it this is because they don't ever want you messing with this. So if you accidentally overwrite the underscore underscore proto, It's like you had to have done it on purpose. There's no way that you could have been like, oh, sorry boss, I overwrote the prototype for the robot by accident. It was a typo. You're like, I don't know. The last time I accidentally typed in __proto _ was never, right? Like, and so that's why it looks like that. It's designed so that you're not supposed to really mess with it. Cool. So if that's the proto, in theory, if one of these, all right, keys pointed to another object, oh, here we go, it's gonna get dicey, which was some more functions, would R1 and R2 be able to access these functions? Yes, right? Because if it's like, hey, in this key, there's this key that points to another one, and this also is going to be another __ proto. So this is kind of how inheritance works for JavaScript. It's like these prototype objects point to another prototype, pointing to another prototype, until eventually it gets to another key that points to another object, and it gets to the capital O object prototype. And the capital O object prototype will be like the second to last. The last thing is technically it points to null, and then null breaks, and null just like finishes you out. So the idea here is that even though I've never built the functionality of robot 5, if I look, there's a proto of object in here. So if I take a look, this is all the key values, the functionality of the capital O object prototype. So it has something called toString in there. So in theory, robot 5 has some sort of functionality called toString. And it exists. It's pulling from the proto of the object. So like this is how the inheritance works for JavaScript. Everything points to another prototype that points to another prototype until it gets to prototype of basic object. Cool? Yeah.
Does the proto come from calling a create method on object?
Does the proto come from? Yes. So
it exists before we tried this way of making a...
Right. So here's how I want to make it clearer, right? Let me actually invoke this because this is something that you've probably seen before. Object. You seen this? So whenever you try to slap an object to the DOM, it gives you this. It's because the DOM doesn't know what to do with JavaScript objects. It will convert it to a string and slap it to the DOM. So that's why you see this. Cool? So here's the thing. Let's actually take a look specifically at robot 1. It was an object literal. So that means that if I look and see what is robot 1, I just get this object here. If I open it, it says name, specialty, and weight. These are the keys inside the object. If I click on the prototype, it just points to the object prototype. Versus when I created the robot 5 with object.create, robot 5, object.create, if I look at robot 5, it's an object with its own prototype. And one of the things in the prototype is the object prototype, which is then all of these functions. So by using object.create, I'm pointing the first prototype object to this template for all of this functionality. And then on top of that, it will secretly do, oh, there's also another key of proto here that points to the object.proto. And it will just keep kind of doing that. Yeah.
2 questions.
Yes.
So, with robot 1, since it's an object literal, why does it still have proto when we return it?
Right. Robot 1 is an object literal. That means that it does not have its own prototype.
Okay.
So the first thing robot 1 has is going to be the object's prototype, like capital O object's prototype. But with object.create, I'm creating its own prototype of robot template as its own proto that also points to the capital O object proto. Okay, so what if there's a better way than this object.create? Because object.create exists in ES5, but now, man, let's talk about this constructor function. This constructor function, right, is basically, let's do this. I have a capital R, and then it looks just like sort of that initialize again. This time I'm using the this keyword. So this, in the context of a constructor function, will be the newly created object. What I mean by that is I can simply do const robot6 is equal to new, and then I have to invoke this method here. So robot factory, and then now I can give it a name. So we got another robot. Huh? Oh, Betamax, sure. And how much does Betamax weigh?
A lot.
Like a lot, right? Great. And then what is Betamax's specialty? Help. Great. So let's actually take a look at what Robot 6 is. Whoop. Oh, embarrassing. Thank you. Oops. Huh? Can I? On line 32. Oh, yeah, that's right. See? Because const doesn't hoist, right? I'm referencing const here before I actually do it. So let's do this. Great. Cool. So what is, let's take a look at robot 1. Oops. Let's take a look at robot 5, right, which is the object.create one. And let's take a look at robot 6. Notice robot 1, again, the prototype is capital O object. Robot 5, while it points to its own sort of proto here, it kind of starts like null, this is not like the best user experience, and then it pulls from the capital O object. Robot 6's robot factory will point to the robot factory that already has the key values because I've initialized it with that. Then it points to its own constructor that I can open. This has a prototype, not the underscore underscore proto. So here's kind of what the main difference is, right? The idea here is that the prototype is the class syntax, and then the underscore underscore is the instance. So robot factory has a prototype, but robot 6 has an underscore underscore proto, and those are the same things. This should return true. So this underscore underscore proto is the key inside the robot 6 that has all the functionality of this prototype object. This is the same thing. The sort of class syntax, right, that template has the prototype, and the underscore underscore proto is the instance, right? The robot 6, the new instantiation, the underscore underscore proto. So far, so good. So that means that if I wanted to add functionality to this, I would have to do robot factory dot prototype, which is just an object. So let's actually take a look at this. Robot 6, robot factory. So what is capital R factory dot prototype? This is what is known as like a very unique thing called the constructor function. In here is where I want to create all of my functionality, in the constructor function object. If I wanted to create some more functionality, I'd put it inside the prototype. What I mean by that is simply if I were to do robot factory dot prototype, it's just an object. If I added more keys, like new functionality, and that's equal to a function, and this simply returned new functionality. Yay. So on the robot factory.prototype, oh snap, I see two things, the constructor and this new key of new functionality. So if I were to make const, what are we at, 7? Robot 7 is equal to the new robot factory, passing in the three things. So name, A, B, and C. So robot 7 is coming from the robot factory. Name, specialty, weight. In this proto, I see new functionality because I added it to the robot factory's prototype object. So going back to this, even like larger scale, I can have a robot factory, right? If this is a constructor function, it's going to build this prototype, and then I just add more to this prototype, which means that every new robot I make will receive the functionality in the prototype object. Sure. It's a little dicey. So I have the robot factory, right? This is a constructor function. A constructor function is noted by a capital. It just wildly uses this, and it doesn't return anything. Those are kind of like the main three things to note that it tells you it's a constructor. What the constructor will do is it will allow you to use the new keyword. This new keyword will point any object I make to the robot factory's prototype. So that means that robot 6 is __ proto will be coming from robot factory's prototype object. So what that means is if I have the robot factory and I use the new keyword, anytime I make a brand new robot, let's just say I use the word new here, what it's going to do is it's going to make a new one, so like robot 7. It's going to have its own object. It's going to be name, weight, specialty, and the first __ proto is going to point to robot factory's prototype. So all of my functionality for robot factory goes on this prototype object. So I have function 1, function 2, function 3. This prototype object, every time I use the new keyword, it's going to do the __, it's going to point to this. So if I do new again, and I make robot 8, it's going to have a name, a weight, a specialty, and then it's going to have its own __ proto that's going to point to where? The robot factory's prototype. So if I wanted to add functionality to 8 and 7, I simply have to add to the robot factory's prototype.
So, like, can you go back to the console, I guess? So, like, how would someone, like, call, because you can see in the robot factory, it's name, weight, and specialty, but we created a function. And it's not like there's another key of that function pointing to the function.
So to make this clear, remember, robot factory is name, weight, and specialty. The __ proto is that hidden fourth key, which is an object that points to the robot factory's constructor, which is an object, which has the new functionality, because when I looked at robot factory.prototype, that's where it was, and it's there because I added that extra key to it.
So how would you invoke that?
How would I invoke what? Oh, sorry, robot 7.new functionality.
So you don't need
No, so it's going to look name, specialty, weight. Oh, there is no such thing as new functionality. Let me look inside the proto. And then it finds it. If I did something like robot 7.toString, what it's going to do is go, wait, is there a toString here? Bloop, bloop, bloop. Nope, let me look in the proto. Is there a toString here? Nope, nope. Let me look at this proto. Oh, there it is. So it's doing that inheritance sort of lookup. Cool?
So the robot factory is kind of like a class that all instances of robots are inherited from.
That's correct. It's sort of like a class that all the robots are inheriting from.
Can you call that though? Like, can you call all the robots in the robot factory?
Not yet, and I'll build that functionality for you.
So does that mean before you add the new functionality, does robot 6 not have that access?
Objects are passed by reference, which means that, yes, if I add it to the prototype object of robot factory, anything after and anything before points to that object. So it will have that backwards compatibility. And you could tell more about this prototype because let's take a look at array. Capital A array. I can look at it. Nope, it's just a function. Great. Let me just look at an array. Really mixing it up there. Dicey. So if I look at this, I'm opening it and I see index 0, 1, 2, length, and then it inherits from this prototype from the array sort of class you can think of. If I look at it, there's all my array functionality. That's how I'm doing it. So if I wanted to add a function to any array, I should add it to what? The array prototype, right? So I can simply go array dot prototype. And I can say, right, monkey patch it. So I'm adding something to the array prototype, and it's just going to be a string that is this monkey right here. Boop. In theory, 1, 2, 3, dot, just added that functionality. And you could see this on the MDN, because if you were to go MDN array, how do they describe everything on here? Okay. Cool. Who's feeling better about this prototype object that's sort of on this main array, but anytime I instantiate a new array, what should it be? If I'm looking at the prototype of an instance of array, underscore underscore proto, and those point to the same thing. And that's how it's doing its lookup. Yeah? All right, cool. So let's keep going. So like we did all this, right? And now in order to extract this, we're going to do the exact same thing we did before, and that is instead of putting the template, I'm going to have to pull this out. Otherwise, I'd create it over and over. So instead of like wasting your time, I've already written the code. I pulled out Robot Factory. Instead of recharge batteries inside the template, right? If I wanted this functionality, I simply put it on the prototype. Now it's recharge batteries on the Robot Factory prototype, which is the function, so that all of these robots have that same functionality. It's to save memory. Cool. So now let's talk about classes in JavaScript. So we talked about the constructor function a little bit. If I actually wanted to, what is the better way to do all of this? What if I wanted to do something like, notice how here, I have robot 7 and it points to Robot Factory. In the same way that if I do 1, 2, 3, 4, it points to the array prototype. The syntactical sugar, instead of doing this constructor function, the syntactical sugar, it will be class robot. There is no do end. I just open it like I would normally. And then I have to build the constructor function. This is a one-for-one representation of initialize in Ruby. So then I would simply have all of this. And because it's the constructor function, I get to use what powerful keyword? Great. So now I can do const robot 7. Oops. Robot 7 equals to new robot. And remember what the new does. New will take all of this and point the prototype to any instance. So now robot 7 underscore underscore proto points to robot.prototype. So if I were to do that and I just instantiate it, now you got another robot for me? Or am I going to go ABC again? That's kind of lame. Calculon?
Yeah.
Oh, yes. Yeah. Oh my God. He weighs a lot. He kind of heavy. 1 ton, 1 metric ton. And what's his specialty? Acting power. Great. So let's take a look at robot 7 then. If I refresh and I see robot 7, I see it pointing to that robot, which means that it should have in its underscore underscore proto the constructor for class robot. So if I wanted to add robot.prototype, I wanted to add a recharge functionality. It's a function. Whoops. And that's just going to return, I don't know, power up. Cool. So what about robot 7 dot, oops, not power up, recharge. And there it is. Because it's the object that it's pointing to. I just added a key to the prototype object for robot, and robot 7 is that instance of the class robot, which the robot 7 underscore underscore proto will point to this prototype. So it has the recharge key, which means that robot 7 now has the recharge function. All right, it's kind of a lot to take in. Prototypical inheritance is bizarre. All right, so let's keep going. So how do we create private methods? Now this is gonna take everything that you learned from before, and I can finally get to the all that has been asked so frequently. So here we go. If you simply put private in here, right, inside Ruby, then anything that follows will be a private method, right? That's what we do with strong params. So how do we do private methods inside of JavaScript? Well, what we can do is we can do this. Let's get rid of this. We can do this. I can have a const of robot. Bear with me now. I get rid of this. This const robot is an anonymous arrow function. It doesn't really matter if I'm using function or not, right? And this right here will return the class robot. So far, so good. Yes, no, maybe so? So if I were to do robot, what is this? What is it? What is it? It's a function. So let's see it. I refresh. What is robot? It's that anonymous arrow function right here as defined. So far, so good. So if I invoke it, what should I get? What is the return value of this const? What is the return value? It's the class robot, which makes sense because when I invoke it, this is the return value. So far, so good. So if I do robot, and that's the return value, and this is just a class, can I then just invoke that class with a name, weight, and specialty? All right, so let's see, A, B, and C. Okay, just kidding. This is a good error to get. The class constructor cannot be invoked without the new. So in order to fix that, I need to bloop. Right? Robot is not a constructor. Interesting. Oh, the anonymous. All right. It needs to be immediately invoked. Great. All right, here we go. Bloop. Where's this close? Here. Cool. So I've wrapped this whole thing inside one level of parentheses, and then I've invoked it. So it should give me that class robot back. So what is robot? There we go. A, B, and C. Cool. So now, because this was immediately invoked, it automatically returned the class robot to me. And it stored the return value, because I invoked it, it stored the return value into robot, which I then just looked at, and then I put new robot here. Cool?
What happens if you look at robot?
Huh?
If you look at robot, that's...
I can't because I don't have a reference to it. I didn't do like const like robot 7 or whatever. But what I want to point out is simply it just created this object, the constructor, with this recharge battery functionality because I built this. So here's how like object-oriented JavaScript kind of works. You have this class syntax. You have the constructor, which is essentially your initialize. And then if you want to add any methods to it, you don't put def whatever like you do in Ruby, and you don't put function whatever like you do in regular old JavaScript. If it's inside of the class, you simply just write the name of the function and then the function definition here. So that means that if I were to do const robot 8 equals to new robot, I pass it in the arguments that it needs, right? Take on me, right? Let's take a look at robot 8. Robot 8. So robot 8 should have a method on it called recharge batteries. This is basically how to write that syntax. You don't really need this yet, and I'll show you why I'm kind of getting to this point. If I, inside of here, simply did a let total robos equals to 1, check this out. If I do this, this.ad equals total robos, what do you think will happen? Each brand new robot I make will have an ID character now on it. And every time I make it, it increments this variable by 1. So let's do this. If I were to do robot 8, I see that it has ID 1. So far, so good. If I make a brand new robot, robot 9, and this is going to be meep, morp, beep. Let's take a look at robot 9. It has ID 2. So far, so good. The reason is because when I created this function, I immediately invoked it. So if you remember from day 1 of JavaScript, a full week and a half ago, it's wild, we talked about closures. And so if I return the class robot, the closure is the combination of the return function and the lexical environment. Meaning, if I add this let total robos inside here, and then it returns this class robot has now stored in memory access to this total robos. But if I look at robot, because this was immediately invoked, should I see this right here, line 87? Well, let's look at robot. I only see the class because this is what was returned. 89 through 100 is what was returned. But robot has stored in memory let total robos 1 because of closure. robot, the const robot on 86, right, is being immediately invoked. So that means that 86, the return value will only be 89 through 100. Because of closure, the lexical environment, it keeps track of 87. It is stored in memory inside that return value. That's closure. And here's the power of closure. If we look at robot now, where is the reference to let total robos? It's not there. You've essentially created a private variable here because once this was invoked, this line right here goes away. But it is still referenceable inside 89 to 100 because of the way scope works. So this is how you create private variables. So far, so good. So if I were to do that, in theory, every single time I make a brand new robot, they're all going to have the same name. So robot 10 and robot 11, the ID is going up because of the combination of the iffy, the immediately invoked function expression, and closure. So that's the private variable. Now, if you want to take it one step further, oh man, if you want to take it one step further, if we were to do robot, which is what exactly? A class, right? If we look at robot, what do we see that Chrome thinks it is at first? A function, right? So this class essentially evaluates to a function. And functions are just objects. So if I wanted to create a class variable, like all, can I do that? So what is robot.all? It's just an empty array. I've added this class variable now by simply adding on a new key value to that robot function, which is essentially a function is a type of object in JavaScript. So how can I leverage this to keep track of all of my robots? Huh? Yes. So like here, I would just put what? Yeah.
When you do like const that being right, they're all equal and right.
Mm-hmm.
And then when you actually do that return class remove, that's when you push into that right.
Correct.
So the array would be
Yeah, I would just, exactly, I would basically put here an all, and then here I would push the brand new instance into that all. And that's basically how I would do it. So the next thing I want to talk,
do you also want to push in like other functionality like recharge battery and stuff?
no, because like this is inside the prototype. If I wanted to build a class method, right? So notice how in Ruby you can have, oops, I didn't do that. Where is that Ruby? Oh no, I didn't do it. Huh? When I do it in the robot? Yeah, I put this class method. Right? It's so easy to do, just self dot the method name. In JavaScript, how would you attempt to make a class method on this robot? No. This one's a lot trickier. It's not as easy as just putting self, but it is as easy as putting static, which is a keyword, and then now class method. Boop, boop. So returns, right? Look, a class method. In theory, I should be able to do robot.now class method. So prepending any sort of methods with the static keyword, I'm allowed to create a class method inside this class.
So you want to make, so you want to make all a static method?
You want to make stack, yeah. So static all, yeah. If you wanted to, you can. Remember, this is just going to be a method on robot, or you can just create a variable here. It's just going to be a key value that adds. So that all being said, the last thing I want to talk about, and then I'll let you go because this was like a ton of information, is there is going to be a tool that you will learn about, and I just want to barely introduce you to it. It's called Babel. So we talked a little bit about the fact that based on your browser, it's going to be loading your JavaScript. If I were to do class syntax, let's actually get rid of all this. Dang it. If I were to put const, or I'll just put var me equals to your boy, this is what it transpiles to. So what I'm doing on the left side is I'm writing ES6 or modern JavaScript or any type of JavaScript. JavaScript will then have to do something called a polyfill. Polyfill will take any of your code, transpile it, and make it so that as if it was written in ES5. This allows maximum backwards compatibility with all the other browsers, because if I backwards compile it, doesn't matter what browser it is, it will run the ES5 code. Well, pre-ECMA script code. Does that make sense? So that means that if I were to tell you something like var only existed back in the day, there's no such thing as let and const. So let equals to var. Ridiculous. All right. So let's actually take a look at like a function. Boop, boop. I'm sorry. Named for sure. Don't want to forget that. And then this is just going to return yeet. Okay. Okay. Look at this automatic semicolon insertion. Powerful. But what if I did const, right? Arrow is equal to bloop, 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 bloop. Return eats for cheats. Turns it to this function. So let's see how it backwards compiles the arrow function syntax in terms of how does it understand and how does it bind this keyword. Well, I can easily just go back into your old code. Boop, boop, boop. So cd into 20. I can pull up the example that we wrote. Sure. This one's fine. Boop. Let's see what happens. All right. In this function, this keyword exists. No big deal. In this bind, right, it binds this. No problem. But look how it handles the arrow function. If I'm doing an arrow function right here, in order to maintain this keyword, because it binds this, right, it will create this underscore this and set it to this keyword. That means that if I ever use this, I actually want to be referring to the old this, the binded this, and that's what it's doing here. It's referring to when this was set here at this location, and it's going to reference that underscore this. What you'll see is, can I type in here? No. What you'll see is the old school way of doing it before the arrow function and ES6 in all its glory, the way that I used to do JavaScript, was very hacky. So instead of underscore this, oh man, it's kind of gross. Instead of that, we're just going to put over here. Cool? It's going to break this. What we used to do, this is disgusting, is we used to go that equals to this and then call that, which was very confusing. So imagine trying to read somebody's code. You're like, okay, var that equals this, and then I call that dot name. You're like, oh, golly. That was no bueno. That was not a good look. So if you ever see that in Stack Overflow, it's somebody who learned back in ye old days, like me. Huh? Been developing for not that long, but before the glory of Harmony JavaScript. Anyways, what a time to be alive. What a time to be a developer. But Cool. Did this clarify a little bit of how this keyword sort of binds, how the arrow function binds this? This is what it will backwards compile into. And so all of this is to say that there's no such thing as classes officially in JavaScript. So if I had this class person, this is what it will look like. It's just a function, and then var person is a function person, and then it does this here. It does something with the constructor. You shouldn't, I mean, aside from the symbols, you should be able to read through this at some point, not right now, and try your best to understand it. This should help your understanding of the this keyword, but all you really need to know is that the class with the constructor will do what with the prototype? Any newly created object with the new keyword will point the prototype of person1 to person.prototype. Cool? And that's how it's doing all of its shared functionality and how it's mimicking inheritance. Cool? All right, are there any questions? Golly, is a lot. Are there any questions as to what prototypical inheritance is, right? That prototype chain lookup. It's just the underscore underscore proto for every single object. Yeah?
Do you use Babel to make your application powerful, or is it just to understand what was
You will 100% be using Babel to make your JavaScript as accessible as possible, because it will transpile it into working sort of like pre-ES6 code. And what you'll see is a lot of React is written in like this class syntax. But how does React websites work if you're still on Internet Explorer? Like if your great-grandparents are still alive, like bless up, and they were on like Internet Explorer or something, and they had to go to your website, which was built in React, it should still work because it will backwards compile. Yeah? You'll learn more about Babel and some other tools like Webpack in Mod 4. But I just wanted to give you like that short introduction about what it is so that you're set up for success.
I don't know if these Babel questions, but if you do come across some ES5 going on the Stack Overflow, will it translate to ES6?
No, it doesn't go. It doesn't go from old to new, only new to old. So that's what the polyfill is, a one-way transformation. I'm sorry. Yeah, I sounded real Canadian there. All right, great. That's all I have for you. Thanks so much.